So where I'm going with this is I'm promoting using appliances for your DNS servers. You might think it's a bit strange maybe using an appliance just to serve DNS or DHCP, but it's actually quite logical when you think about it. When you think about how routers actually started, routers started as just a process that was running on like a mini computer or a Unix box. So those eventually got replaced by Cisco routers, which is basically an appliance. NAS filers have come along now. Those are basically replacing your Windows and Novell file servers. Even firewall appliances like the Nokia boxes typically replaced a Sun Solaris box running Checkpoint Firewall 1. So you can see that there's an evolution going on here, and currently there's quite a few appliance vendors now with DNS DHCP solutions. So it's perfectly logical to go down the route of deploying appliances. And some of the advantages you get is you get total ownership of the platform now. You don't have to go to a separate team to get more storage allocated or to get the Unix operating system cleared out. You've basically got ownership of that appliance, which also means you won't get other applications running on that appliance. So it's purely dedicated to running DNS and DHCP and those other core network services I talked about earlier. So you've got no unnecessary ports now, so they're a lot more secure, and the operating system will be hardened. No local user accounts or even no access to the local operating system. Normally these appliances just give you a cut-down shell which allow you to run certain troubleshooting commands. Patches and upgrades as well. You may find DNS has suffered from numerous vulnerabilities over the years, so there's always patches and upgrades to fix like DNS issues. And with appliances, it's a lot easier to apply those patches. Typically, it just involves uploading onto a management box, and then it just gets distributed out to all the appliances. So you don't have to worry about getting the Unix guys to download the latest version of Bind and compiling it and then uploading it and testing it and installing it. And appliances normally give you additional features such as high availability, where you can have two appliances in like an HA pair, and you have a VIP, a virtual address. And also things like Anycast technology. Now, you might not have heard of Anycast, but it's in use extensively on the internet to provide resilience for the internet root servers. Traditionally, the root servers on the internet have been a focal point of attack. Up until a few years ago, there are actually only 13 root servers on the internet. And there still are only 13 individual IP addresses that are advertised for all the root servers. But most of them now are using Anycast technology, where the same IP address is used on multiple servers, and it's the routing infrastructure that decides which server you actually get routed to. And we're seeing now more and more of these DNS appliances implementing Anycast technology, so you can use it internally on your internal network. So you could have half a dozen DNS servers all using the same IP address. And OSPF, for instance, will just route you to the nearest server. So I normally advocate a holistic approach to DNS management. The first thing is to sort out who owns the DNS service. I was talking about earlier how it can often fall between the cracks, and there's teams that don't necessarily want to be responsible for it. So what I would suggest is you actually nominate a team, maybe have a dedicated team that's responsible for looking after and owning the DNS service. They can also coordinate requirements from different projects to make sure that they all coordinate together. Obviously, I'd recommend using dedicated servers or appliances. So, there's nothing wrong with using DNS on your domain controllers, but I would personally recommend getting DNS off, running it on a dedicated platform somewhere. And obviously, place DNS service in your data centers or at the core of your network. So everyone knows the IP addresses of your DNS servers. If you start rolling out DNS everywhere on all your DCs, you could end up with, 30, 40, before you know it, 50, 60 DNS servers. And then you've got people using all sorts of different IP addresses. And trying to migrate people off in the future, if you've got a network change, is an absolute nightmare. So just try and, I'm an advocate of keep everything simple, keep it centralized. Obviously ensure your WAN links are resilient. If you're using a centralized DNS service, then if you don't have resilient WAN links, then you might want to look at deploying a local DNS server, which might just be a caching-only server or a secondary. Ensure the server or appliance you deploy is resilient. So use RAID 1 disks, dual power supplies, UPS, all this kind of stuff. It's all pretty standard stuff, really. Make sure you've got out-of-band management. So if the server's down on its knees, you've still got another way of getting in. So with HP and Dell boxes, you've got obviously DRACs and RILOs. Most of the appliances out there have also got console ports. So if you're using terminal servers or console servers, then you've got another way of getting in. And monitoring as well, big thing. They all come with SNMP agents now. So you can set up, I mean, these are just some graphs from Cacti, which is just a free bit of software you can get. Monitor your DNS servers, make sure they're performing adequately. So last thing I want to talk about is DNSSEC. Now this is something you're going to hear more and more about. It's being shipped now with Windows 7 and Windows Server 2008 Release 2. It actually comes out of the box. The main reason for deploying DNSSEC is to authenticate the DNS traffic. There's a lot of stuff in the news at the moment about Gmail and Yahoo accounts being hacked through phishing emails. There's also cache poisoning attacks going on with the DNS. So the idea of DNSSEC is it adds a digital signature to the traffic, the DNS traffic, so you can check if it's been tampered with and if it is actually, Amazon.com that you're going to. Now DNSSEC involves quite a lot of work in the DNS infrastructure to get all the domains actually signed with these cryptographic keys. But some of the domains are already signed, like .sc, Sweden, .org and .gov, top-level domains are already signed. .com is going to be done by 2011. They still haven't signed the roots yet, but that's coming along. So hopefully in a couple of years, the root servers will be signed. You may not need to deploy this internally, but for your external DNS infrastructure, this may become more and more important. So this is just to warn you that this is coming. And you're going to hear more and more about this. Okay, so that's the end of my presentation. Thanks for your attention. We're actually running a DNS surgery on our stand, which is literally on this section here, so just outside the door. We're giving away free beers as well, so if you want to come along, have a chat with us about any issues you might have. All we ask is that you just fill in an information sheet with some contact details, and then we'll bribe you with a beer token, which you can get a beer from the bar here. Okay, so thank you very much for your attendance. I hope you enjoy the rest of the show. If you've got any questions, I'll literally be on the stand, so you can just walk over and just come and have a chat. Okay, thank you very much.